Hello, this is a quick introduction on Screencast-O-Matic, a little bit of how to create a snail cam, which is one of the cams that you'll be using for the Automata and testing simulator. And there's lots of ways to make this snail cam, and you can search on YouTube and find a bunch of different strategies using arcs and circles primarily. The directions show kind of a central point. Snail cam is a little bit off center, so I'm going to start by putting a circle just below the origin point and without any dimensions placed on this. But roughly, I would say 1/2 inch. And then I'm going to place another circle that's slightly above the origin. And ultimately, I want the bottom of both of these circles to be tangent to each other, so somewhere in this general vicinity, and about 1 inch is okay for this as well. And in the center on the origin, I'm going to use a rectangle tool called the 2-point center rectangle, and go ahead and set that right on the origin. And this will be a 1/4 inch square, so 0.25, 0.25. Okay, having made that, I realize the two circles that I started with are way too small. Okay, so I'm going to go ahead and apply a tangent and tangent between those two circles. I'm also going to use the vertical constraint, and I want the center of these circles vertical with the origin, or the center of the square now. Whoop. Okay, I'm going to hit escape. Now if I right click and show all constraints as a feature, we can see if all of those constraints got placed properly. It's also the F8 key. And so there's my horizontals. The square have its own constraints, and then there's the tangent. Okay. So like I said, these circles are too small. I think I was looking for a 2-inch kind of overall diameter, which would mean like a 1-inch radius of this bigger circle. And we are going to apply some dimensions to that in just a second. All right, so what I want to do is I want to take the dimension tool, and I think I'll come back and do that in just a second. So the other part of this snail cam, what makes it a snail, is that there's a kind of a drop off here. And so I'm going to place a point and draw a line down vertically to connect those two circles. And then and it automatically, you might have seen that it automatically applied a vertical constraint on that line, which is good. And I just want to make sure also that that line itself is vertical. Yep. So, and then maybe the point is vertical with the center. And you see that kind of snapped it in place and turned it blue, which means that that's fully constrained. So the square and the circle. Okay, so now I'm going to use the trim tool. And there's the little scissors is the trim, or the letter X is the shortcut key. And I'm going to trim this left side of the big circle. And I'm also going to trim the right side of the small circle, leaving me with a very small snail cam. Okay, so I'm going to get off of the trim tool, hit escape. Now ideally I should be able to kind of click and drag these circles and like resize them. Oops, undo. There we go. That's working a little better. All right, so I have no dimensions on either of these circles, but I'll kind of toggle back, and if you look at the and they're screencast-o-matic. Talk more about that during the meeting. If you look at the cam drawing dimensions, it does show you that the smaller arc is about halfway, or they're using 1/4 D, which is the diameter. So it's a half of the radius from the hole. Okay, so come back to here. And so whatever dimension you're trying to get overall, this will be 1/4 of that full length. So I'm going to dimension from the center to this point, if it will let me. Let's try again. Dimension. Sometimes with the constraints visible, it's a little hard to dimension, so I'm going to hide all the constraints. That's the F9 key. There we go. And I was looking for 2 inches overall, so 1/4 of that would be 1/2 of an inch. And then to the tip will be a full inch, so 1 inch. And that's roughly what I'm looking for. You'll notice it's not fully constrained because the center points are kind of just floating randomly. If you try to apply a dimension to the one of these arcs, it will fully constrain it. It's kind of up to you. I would think maybe just leave them floating is the best strategy in this case, because those 2 dimensions are really the only 2 that are driving the shape of this object. So I might leave them as such. The only thing we could do is expand and kind of change the profile of this snail. So that's kind of up to you how large you want that to be. All right, so that's basically the outline of the snail cam. So I'll finish the sketch. Go ahead and extrude that. And this would be kind of according to whatever material you're using. If you're using that corrugated plastic, I think it's 3/16 of an inch. If you're going to 3D print or use some kind of plywood, you might adjust that as needed. So I'll just go ahead with 3/16. So I think that'll be consistent with the other examples. And okay, so there's the basic snail cam. And again, this kind of depends on what material you're wanting to use. If you were going to 3D print this, you might put it on some type of plastic, ABS, or that was a good example. All right. And the other thing needed for the assignment is you do have to create some work planes. So I'll go ahead and demonstrate that while we're looking at this. And you want a work plane, and hopefully you use the origin because that makes it a lot simpler to place a work plane, because I want a work plane that's going vertically, one that's going horizontally through it, and I may also want one that's kind of slicing it in half. So using the work plane tool, sometimes it will automatically place work planes. It kind of picks the best strategy, and there's a lot of different work plane options. One that I've used for this assignment is mid-plane between 2 planes. And the way you can use that is you can select the 2 insides of this hole cut out. But another thing that's usually pretty handy if you use the origin in the creation of this object is if you hover over, open the origin folder and hover over through these, you'll see those work planes, and those are the 3 that we could work off of. So one thing you could do is just select work plane and then come over to the model window and just click on that YZ plane, and it will go ahead and set your work plane right on that. And then I'll work plane, and then you just hover over near it, and you'll see you kind of have to select the outside of the object right there, and you'll see that it turns yellow. It's a little bit finicky sometimes. That it? That's the one I want. Okay, that is not good. It's too skinny. And I think you can go in and resize these work planes. I know you can, but I think I will undo and try a different strategy. Now this one's called midplane between two planes. So you just select one of your planes, and I'm going to rotate the object and select the other. And that gives me a kind of a work plane that's a little bit easier to work off of. And I'll do that same strategy here. So that's one way you could do it. Something that would have worked equally as well is just to right click on the XZ plane and just turn the visibility on. And that's basically, that is a work plane. So quick, easy way to do that. So either of those options. Now the one slicing through the middle will be best to do midplane between two planes as well. So we'll select the front, select the back, and now we have three work planes that kind of dissect the cam. All right. And the final thing we want to look at in this is a properties, iProperties, to tell me what the weight and mass and all the other details, volume. So to get that, you can right click on the part in the model window and just select iProperties from that drop down list. And under the physical tab and sometimes you have to click update. Notice the mass, and that none of these are available until I click update. And there it generates the mass in pounds, since we're using the standard IPT, area and volume. And this is a good way to check if you've given specific dimensions to see if a student has created the part correctly. This is a good way because you'll get up to 3 decimal places. Also, you get the center of gravities and some other things. The density, since I picked ABS plastic, is shown here at 0.357 grams. Okay, so there's a really quick run through on using Inventor to create the snail cam and to check the iProperties and generate work planes.